This might be interesting for some of you. What I've got here, I'll show you a little bit better in a minute, but in here I've got a ball bearing which is sitting on a conical surface, and my requirement is to position that cone very accurately axially along the spindle of the lathe. And one of my videos was making this little dial gauge holder there, and I'm using it to measure the distance from the top of the ball to that face, this front face on this tool here, and the dimension I'm looking for is 4.45, and I'll just show you that I've crested. So if I wind the carriage back and forward, so the highest point is there, so the dimension is 4.72, so I need to remove about 0.25 or 0.27 millimeters to be precise. So I'm going to do that now, and I've got the carriage locked in this position, so it's not going to move. But what I will do is take the gauge out, just to make a bit of room for the countersink to come in. Okay, so in there, this little conical surface in there, which I've produced with my countersink. It's not the most accurate way to do, or the most controllable way to do this, I should say. So with about 10 hands now, I'm going to try and put the ball in. So the ball goes in there like that, and I need to hold that with my finger and then put the gauge back in there, which I can't do whilst holding the camera, so bear with. Okay, with a bit of camera magic, we're back in the room. As you can see, the probe is not central, so I'm going to wind that in now. I haven't measured this yet, I've just taken a lick off it with the countersink. So I'm just finding top dead centre, which is there. So I've removed very little. I've removed 70 microns, so I've got another 200 microns to go. So we'll do that and come back to you. Thought I'd show you this just for amusement. You could probably fit a rizzle of paper between them. Well, a bit more than that, but you get the point. There's not a lot of clearance. Anyway, I'm going to, let's fire this up. I'm going to just take off a small amount. I can't really say how much I'm removing because I don't have a readout on the tailstock. Just looking at these divisions. Right, let's give that a blowout. Yeah, back in a sec. Okay, let's have another look then. Okay, so that measures 4.4, no it doesn't, 4.57, getting on 4. So another 100 mics to go. Okay, we're pretty much there now, I think. Just crest that curve. So it's just a shade over. So if I can get in a bit closer. Yeah, a bit of parallax, but if you look at the shadow, it's just over 4.45. Okay, so I'm going to call that good, and just to show you, focus, the wall's going to fall out now, but that's okay. So what's going to happen now is I'm just going to show you back to the reference surface. Come on, focus. We're on 0. almost perfectly on 0, but not quite, but it's maybe half a division, so about 5 microns out. So worst case, about 10 microns error on that, which that's okay for what I'm doing here. In summary though, I was trying to find an easy way to measure that dimension with the part on the machine, because obviously you don't want to take it off and on again because there's a repeatability error there potentially. So that's just another use for this little dial gauge holder, which has proven itself to be quite useful.